Let's go through example number 5 for the mean value theorem for integrals. We have the bare population, P of t, so P for population, after t years after the year 2000 is given by the following table for Randolph County, Virginia. Now, don't remember where I found this example. I think it was from the Virginia Department of Wildlife. Forgive me for not citing it. But anyways, it's just a simple table. Here's how it works. So at 0, so at the beginning of the year 2000, there were 173 bears in Randolph County. Okay. After 1 year, so at the beginning of 2001, there were 200. After 2 years, at the beginning of 2002, there were 197. 3 years, there were 234. And 4 years, there was 260. Now, this question is asking for the average population. Well, let's go ahead and read this together. What is the average number of bears in the county from the years 2000 to 2004? Okay. So at 2000, our time is going to be 0, right? And then our ending time, or our b value, is going to be b equals 4. And when I first, well, that's a t value. So our a value is 0, and our b value is 4. So from t equals 0 to t equals 4. When I first read this question, I was like, well, why not just add all these up and divide by 5, right? There's 5 total populations. But what I didn't realize, and what I didn't really think through, think about from 2000 to 2001, the population went up from 173 to 200. Here's what we're really getting at. This is a continuous function. Okay, so it had to continuously go from 173 to 200. Then it had to continuously decrease. It went down to 197. And then it went back up again for the remainder of the time. It's a continuous function. And so we have to treat it as such. And so we can't just say that miraculously after a year it jumped from 173 to 200. No, it continuously changed. The bear population changed in this county. So because of that, we can't just add all these up and divide by 5. We have to find the area under the curve and multiply by 1 over b minus a, in this case 1 over 4. So that's the real difference. We're going to go through the steps that we did and all the other examples, and we're going to figure out why that's different. So step 1 is to label the interval a to b. So a equals 0, b equals 4. Step 2 is to write out the formula for average value. Again, it's 1 over b minus a times the integral from a to b of f of x dx. Not sure why that integral is broken there, but I'm going to go ahead and fix that. Step 3 is to plug in f of x, a, and b. Well, for right now, we just have a chart. So in a second, I'm going to show you how to basically take this chart and turn it into a graph. Okay? Because we don't have a formula, but we can find the area of a graph, right? So take any chart, if you're doing average value, and make it a graph so that you can find its area. This part's easy, right? That's just going to become 1 over 4. And we're going to be taking 1 over 4 and multiplying by the area under the curve from 0 to 4 of our graph. So let's go ahead and do that. So step 4 is to determine the definite integral. Let's read this together. It says to determine the definite integral of a chart, let's write that, we need to graph the function and use Riemann sums to compute the area. So basically what I've done here is I've taken this chart right here, 0, 73, 1, 200, 2, 197, they're all points, and I've just plotted them on this graph. Okay, so again, P of t gives us the bear population after t years after 2000. So for example, at the year 2000, 0, there's 170 some bears. I plotted those 1, 2, 3, 4, 5 points, and there you go. So to find the definite integral, what I can do is I can make a little chart or a graph out of this by connecting the dots. And that's what I'm going to do. The way I figured, and there's different methods you can do, I'm going to do trapezoids. Why? Because trapezoids tend to be a little bit more accurate than just rectangles. So if I draw these trapezoids here for this graph, I can find the area under the curve of our bear population to figure out the average value. Now again, what is the average value trying to figure out? It's trying to figure out the average bear population from t equals 0 to t equals 4. So just somewhere along the line here, the average of all of our y values, these pink dots, there's going to be some dot or here that's going to represent the average bear population. Because it's a continuous function, though, I want to use Riemann sums to find the area under the curve to get a better approximation. In other words, the population didn't go from just 170 to 200 magically, it was continuous. Now, is this necessarily what the graph would look like? No. I mean, the bear population could look something like this. It could have went down and then back up, and then down and then up, okay, and then maybe up and then down like this. That could have been the case, in which case the average value would be different, right? I don't know what the graph looks like. I just have these 5 points that were given to us in the chart. Okay, and because of that, my best guess is to use trapezoids. Okay, again, another thing you could do is just add these up and divide by 5, but it's a continuous function, so I want to do it this way. Okay, so use the shortcut formula for trapezoid Riemann sums. Basically, what that is 1/2 b, 1/2 times the width of each trapezoid, or the base, times the first height, the last height, and then double all the heights in between. Okay, the other way to do this is actually just to use geometry to find the area of all these trapezoids. And I'm going to shade that in purple. And remember, again, the area of a trapezoid is 1/2 times the base times the average of the two heights. So it's another way to figure out all these. So for example, the first one would be 1/2 times this height plus this height divided by 2. Actually, just scratch the divide by 2 part. That was redundant. It'd be 1/2 times the base times h1 plus h2. So it'd be 1/2 times 1, which is 1/2, times this height plus this height. So it would be 1/2 times 173 plus 200. That's going to give us the area of the first trapezoid, and so on and so forth. But we can use a shortcut, just double all the middle heights, and then add the first and last height, and then multiply by 1/2 times the base. So that's what we're going to do. 1/2 times the base times the first height plus the last height plus double the middle heights. And then that right there, if I crunch all these numbers, is going to give me 847.5. Now that's the area under the curve here. So all this purple is 847.5. However, to figure out the average bear population, I'd have to multiply that by 1 over b minus a, or 1 over 4. And that will give us this average bear population from 2000 to 2004. Okay, so I'm taking that, I'm plugging it in to this part right here. That's the area using trapezoids, and I'm multiplying that by 1/4. And if I do that, I get 211.875. Let's answer this question verbally together. So there's an average of around 212 bears living in Randolph County at any given time from the year 2000 to the year 2004. Special note, okay, so going back, so again, looking at the graph, I always like looking at the graph. The average bear population, I was really close, right? I was right there around 210. So the average bear population at any given time from 2000 to 2004 is 212 bears. But here's our special note. The table gives data for the bear population at the end of each year, or the beginning of each year. Beginning of, for example, beginning of 2001 into 2000, whatever. You might think that adding up the populations dividing by 5 would give you the average bear population, but it doesn't. That number gives you the average bear population at the end of each year, not the same thing. So we have to consider the fact that it's a continuous function. We wouldn't want to add them up and divide by 5, because that just gives you the average bear population at the end or the beginning of each year, basically at January 1st. It doesn't give you the average bear population at any given point in time, which is why we drew this graph, to show that it's a continuous function, and 212 is a more accurate representation by using our average value formula. If we were to do it the other way, you can go ahead and do that on your own. I don't want to confuse you. You would see that you would get a different number by adding all these numbers up and dividing by 5. So that's it for this example of the average bear population from 2000 to 2004. If you have any other questions about it, let me know.